Good morning. Good morning, everybody. So one of the waypoints there in my introduction was my first stereo system. So, everybody familiar with the Cold War? There was a second Cold War you guys probably aren't familiar with. My dad and my uncle, they constantly were trying to outdo each other with their stereo systems in the 70s. Because what did you need to be an awesome dude in the 70s? You needed a Corvette, a mustache, and a stereo system. So anytime my dad or my uncle upgraded their stereo system, my brother and I were treated as third-party developing nation puppets, where they would try and buy our affections through what they thought was obsolete stereo systems. So by the time I was 10 years old, I had 2 cassette decks, a dual turntable, an SA8500 Pioneer, and a pair of K-H speakers that I probably still couldn't move today if I tried to. So that's how I got into hi-fi, which was pretty awesome. So when I grew up, or when I was thrown out of the house, I had to get a job, and I thought, well, I got a job in a hi-fi store. I read stereophile. I know everything, and sort of the rest is history. So who was in the seminar yesterday? Okay, decent amount of people. Hi, Gail. It's good to see you. So the last couple of years, I've been just doing one quick and dirty seminar, and then there were always more questions than could be answered because I get an hour or an hour and a half. So I divided this up into 2 different segments. Yesterday, we talked really about the basics, getting iTunes set up and optimized, and just kind of getting familiar with hardware requirements. Today we're going to go a little deeper. I want to talk about some different player applications, and also I really want to dive into network audio. I've never really covered publicly network audio in one of these symposiums, and I think this is probably as good a time as any to give it a try. So I do a lot of network media at home. I do locally connected devices like USB DACs, but in terms of architecture for the house, the audio and video system, I do a ton of networking, and I find myself becoming the IT guy in our community, and helping everybody get their Apple TVs set up and their smart televisions and things like that. And so clearly this is an area where people have a lot of questions, and I thought this would be a good thing to try and pass along. So who here has a television set? Who here breathes oxygen? Who's got a smart TV? Anybody got a smart TV? Okay, keep your hand up if you have a smart TV. Who's got it on the network? Okay, decent amount of people. Who'd like to have their TV on the network? Who doesn't know what I'm talking about? Okay, it's okay. Who's got an Apple TV or a Roku? Or Sonos? Who's got a streaming DAC? Anybody got a streaming DAC here? Anybody doing audio over the network now? Okay, a few people. Who would like to do audio over the network? Who doesn't know what they want to do? That's an honest man. So what I want to do is I want to jump in. I want to talk about networking audio. Let's start with what are the ingredients we need for a network. So who here has heard about the internet? Okay, who's got a router and a modem in their house? Who's got service? We all have service, right? Okay. So that's the baseline for what you need if you want to do network audio. You need the router modem that you got from whoever your supplier is, your provider. It could be Comcast or AT&T or Verizon or Cox. It just depends on what part of the country you live in. This is a router. This Airport Extreme I have here is a router. What you need then is you need some sort of networking audio device. It could be something as simple as an Airport Express. These are $99 devices from Apple that can function as an endpoint. You can play to them over iTunes. They have a little 3.5 millimeter plug on the back of them, and it's either Toslink or it's analog out. So you can actually use this as a device to get to another zone. So that's the 2 basic pieces you need if you want to build network audio system. You need a router and you need an end device. And end devices can get real sophisticated. There's a multitude of different devices. If you've seen what Name and Lin, 2 pioneer companies, they're 2 very pioneering companies in this category. Their streaming devices are absolutely spectacular. If you have a smart television, it's a streaming device. Anybody bought a Denon or a Sony or a Pioneer receiver in the last, say, 5 to 8 years, it has networking capability built into it. And I'll talk about about the different protocols. But I want to talk a bit about the hardware. So you've got your router and your modem that comes from the cable company. Now guess who built that for the cable company? The guy that came to the table with the lowest bid. So they're typically not very sophisticated devices. You'll typically want to just treat that device you got from your networking service provider as just the modem, your gateway to the outside world, your gateway to the internet and to things like iTunes and Netflix and Pono and HD tracks and those types of things. What you'll want to do is get a more sophisticated router for the house. What I like to use is something that can do up to gigabit speed. So you'll see speed ratings in the back of these routers. Typically they're rated in 10, 100, 1000 or 10, 100, 1 gigabit, 1000 and gigabit are the same thing. So you want to get one of these routers. Then what you need to do is you need to determine how many devices, how many locations in the home do you want to get to? Is it just one location in the living room? Do you have 3 locations, 5 locations, 8 locations, 12 locations? You need to start to map that out, decide how many locations in the house you want to have, and then what you probably are going to need is something like this. This is called a switch. The switch works in conjunction with your router. So your router is the device that's going to assign all the addresses. The router is going to give each device that goes on the network an address. So at home, my router starts at 10.0.0.1, and it goes up from 0.1 all the way up to 256. So every time I add a device to the network, that device is going to get a unique IP address. That is so that the two devices can discover each other and send the appropriate data to them, and that everything winds up where it's supposed to be. The switch does not have that capability to do that. The switch works in conjunction with your router. So think of this as the brain, and this is the nervous system. So you have your router, and then you have your switch. Now, where people sometimes stumble with the switches is they'll confuse a switch and a hub to be the same device. A hub is really just a single IP port with expansion ports on it. So you're splitting up that one address across as many ports as there are. I always suggest to people stay away from hubs. They're fine in an office where you have printers and things like that, but for an audio video media system, I would say stay away from things like a hub and stick with a switch. Okay. Who has 4 or 5 people in their household? Most of us, right? Or more. So one of the things you might want to think about when you're laying out the architecture for your network is how can you segment the network where you can optimize traffic flows? So this is a really simple thing to do. Let's make a hypothetical situation. You're a family of 5. You've got 3 kids that are on Facebook and YouTube and Vivo and Twitter all day long. And they're eating up tons of traffic, uploading and downloading videos. And you go into your hi-fi room and you want to play your high-resolution files. You want to listen to your music. Well, you're probably going to have enough bandwidth on your network to do all that stuff while your kids are doing this and while somebody maybe is downloading Netflix. But you may want to design your network so that you have the shortest paths between the different devices. So what a lot of people with network audio do or network media do is they have what's called a NAS. This is a network attached storage device. This is a hard drive that's on the network. This device has its own logic just like a computer or a phone, okay? And it has its own IP address and it's sitting on the network, and my computer can find that device. But do I want to route the music from that device out into the whole house, compete with traffic, compete with potential congestion in the house with everybody else in the family, or do I want to create the shortest, quietest path between this device and my stereo device? So it's a really simple thing to do. We could add a second router. So we've got our modem, we've got our router, and then we had a second router just for the media system. But what we do is we go in and we configure that router to be a bridge. So what we're going to do is we're going to take it off of we're not taking it off, but we're creating a segment now where all that traffic my kids and anybody else in the house are creating with wireless, with Netflix, with Vivo, and uploading this and that from Facebook. My media is not going to compete on that highway. I'm going to create my own sub-highway. So let me show you what something like this would look like. With an Airport Express, I can go into what's called Airport Utilities. And I can edit this device. And right now, it's functioning as a full router. You can see it's doing DHCP, so it's assigning addresses. Or what I can do is I can just simply convert it into a bridge. So now what it's becoming is a super intelligent switch. It's functioning like a switch with its own capabilities to think. So what's going to happen when I turn this router into a bridge, I'm going to plug all of my media devices into this system. And what it's going to do is it's going to be able to find the address between the computer, the NAS, and the playback device, the streaming device, whether that's this streaming DAC over here, or it's this Airport Express, or this Apple TV. And it's going to be able to create real short paths where I'm not competing with traffic with everybody else out in the household. Okay, so I'm going to hit pause and ask you guys if you have any questions about this stuff so far. Does it make sense? Yes?
So you took a second router in your first, and your NAS and all your equipment into that.
Into the second router. But what I'm going to do is I'm going to change the router's profile. It's no longer a router now. It's a bridge.
Fine, but this is on, what are you going to do with the PC? An Apple.
Well, the PC that's in the media system, the PC I'm using, the PC I'm using as part of my stereo system would be on this side as well.
Compatible with that.
You don't want to use that.
Oh, this is just an example. This is how all routers work. It could be a Mac, it could be PC, it could be Linux. This is how all routers function. This just happens to be the setup tools for this particular router.
You can get a second Netgear router.
You can mix and match. Yeah, you could mix and match. You could have Cisco, you could have Netgear, you could have Acer, you could have Apple. Doesn't matter. They'll all have their own unique windows and menus to set up their devices.
Can you talk more about using a NAS versus a streaming device? Like, why wouldn't I want to just use the NAS and playback on my PC or playback on other devices? When does the streaming device come into play?
You mean the end device that makes the music?
Well, I guess I'm missing something. So the end device would be like a stereo?
The end device would be, a stereo that connects to the network.
And that would require a streaming device in order to read those?
Yeah, it'd be the end device, and you need the source device. So the source could be a computer and/or a NAS, and then the end device would be something like this Premiere that has streaming inputs into the back of it, or something like this that has a streaming input and an audio out.
I think his question is, what's the difference between having a NAS as a source for the music and a dedicated streaming device?
Well, okay, that's a good question, and I think what ultimately you need both. So let's talk about a streaming device. So this is the final piece of the puzzle, the streaming device. It could be something like this Apple TV, or it could be something like the NAME device. Anybody here familiar with NAME Electronics? Okay. NAME makes a number of different streaming devices, and those streaming devices have an app that you can put on your Android or your Apple device, your iPhone, your iPad, and Android. That app will then, you can configure it to discover where your music is stored, and then to discover the NAME device. And then what you can do through that application is you can say, I'd like to play this song to this device. Does that answer your question? And we're going to do that in a minute. I'm going to demonstrate something like that in a minute for you.
So I have a Synology NAS, and I think it has, the Synology, I think it has some streaming apps that go in it.
It has serving software. Yeah, so it can serve the media. Now what we have to do is we have to receive the media.
So that could, like if I Android device, I could put a Synology applet on there, and I think it's not, isn't that the same relationship?
It is, but I think for now, I think your questions are good. I'm going to demonstrate how to do this, but I think right now can we hold those questions, and let me see if I can answer those through through demonstration. I really want to take questions just on the hardware now that we talked about for the network. And then the next section I'm going to jump into, I think, what you're asking for.
The router that you're using as a bridge, does that have to be hooked up to the internet if you're just using the NAS as your source?
No, if you were just going to use it to create an address between your music source and your playback source, it wouldn't have to be on the internet. And it doesn't necessarily have to even be on the whole home network if all you're going to do is just have, let's say the most basic system you would have is you had your NAS with all of your music on it and your streaming player like a name. And all you want to do is take music from the NAS to that streamer. You just need a router, and it doesn't even have to be connected to the whole network in the house if you're not going to the internet. Yeah.
If I have a DAC, if I have a DAC and a NAS, what do I need between them?
If you have a DAC and a NAS, you just need the router so that something can work as sort of the train station and assign the addresses and send files from this service point to the end point. Well, we're not talking about USB. We're only talking about network today. We did USB yesterday. You take a computer and you take a USB cable and you connect it to the USB DAC and you're done. I'll show you. So there seems to be, the questions that I'm getting now seem to be beyond the network, the actual network components. You guys seem to be clear on that. So let's jump into the next section and I'll start answering these questions for you. So I'm going to close this down now. And now what I'm going to do is I'm going to bring up a program called J-River Media Center. So this is a really interesting program. J-River Media Center is when we're talking about network media, it's a dual function program. It can serve music to the endpoint, to the playback device, but it can also retrieve the music from the source device where the music is stored. Music can be stored on your computer, it can be stored on a NAS, it can be stored on somebody else's computer. If somebody else's computer has permissions set, where other people are allowed to look at those music files. So let me show you how this works. It's real simple. So the first thing we'd want to do is we'd want to discover where our music is. So we would go into Library, and we'd go into Import, and then we would configure our import, and then we would browse for the music that we want. So I'll go ahead and I'll click Add, and then I'll browse. And in this particular case, what I've done is I've selected, I want the music from my NAS, my Go Home Flex. So what I'm doing now is I'm telling J-River where all the music is. So this is already done. I'm going to go ahead and cancel that. The next thing I need to do is I need to go in and I need to tell J-River I want it to serve music to different devices. So let me show you how you do this. In J-River, they have what's called tools and then options. And if you look in the option tree, you see this insignia for the DLNA, Digital Living Network Alliance. And I click on that tool, Media Networks, and then I go to Add or Configure a Server. So what I'm going to do is I'm going to turn my computer into the server. So I'm going to retrieve media from the NAS, and then I want to serve it to something. I want to serve it to a media player. So what I'll do is I'll add, and it'll ask me what kind of devices do I want to add. It's hard to see up there, I apologize. The first one is an audiophile DAC, and an example will be anything 24-bit. A legacy device, so DLNA, I should hit a timeout here for a second and explain what these protocols are. So for streaming, there needs to be some sort of language for the devices to speak to one another. So everybody here has heard of AirPlay, right? That's Apple's streaming protocol. AirPlay is a protocol that allows the devices to see one another. So AirPlay allows iTunes to see your phone, or to see an Apple TV, or an Airport Express, or a third-party product like a Denon or a Pioneer or a Sony that has AirPlay in it. And what it allows is for your music to move from one media point to the next media point. So that's a very closed system that Apple's created called AirPlay. The rest of the world uses a protocol called UPnP DLNA. Think of UPnP as the foundation and DLNA as the house on top of the foundation. Has anybody here heard of DLNA? Okay. Don't feel embarrassed if you haven't heard of it. They're terrible at marketing themselves. There's something like 6 or 7 billion DLNA devices on the planet right now, and nobody is aware that they exist. So who's an Android user? Who has an Android phone? All your Android phones are DLNA compliant. Your smart TVs work on DLNA. Roku works on DLNA. There's tons and tons and tons and tons of DLNA devices out there. The trick is figuring out how to get all these different devices to talk to each other. This program, what I'm about to show you here in this program, this makes things easy and elegant to do. So we loaded our music files in. Now we've gone into the tools and options, and now we're in the network configuration. We've told JRiver we want to be able to stream music. Now we want to create a server point. So we'll just leave this one as it is, the audiophile DAC, and then it has some configurations under audio. In audio, it'll ask you if you want original. What original means is, do you want to play the file in its original format? So here, who here has FLAC files? Okay. Who's got Apple lossless files? Who's got AIFF files? WAVE. Okay, I know this is a dirty word. You can admit it. We're all among friends. Who's got an MP3? Okay, only a few of you will admit to it, but I know everybody in this room has an MP3 somewhere. So DLNA is a little tricky because it's not necessarily going to be compatible with all these different file formats, and sometimes the file, the extension, is written differently. So I'll give you an example. So AIFF can be written as .AIF or .AIFF. And your FLAC file could be .FLAC, but it can be lowercase or capital F. And these little things can throw the whole system off. It could make it so devices aren't compatible with each other. So for example, on the streaming device I have at home, I have a Pioneer N50. It will play any file that's got an extension of .AIFF. But if I send it a .AIF, the system crashes. And it's just the complexities of networking. Anybody here an IT person? Anybody do IT for a living? Anybody here held hostage by their IT person? So that's, yeah, IT can be very tricky. So JRiver came up with a very, very clever solution to all this. For DLNA devices, for end devices that can receive music over DLNA, they have to be compliant with only 2 media formats. They have to be compliant with raw linear PCM and MP3. They don't have to be compatible with FLAC. They don't have to be compatible with AIF or Vorbis or OGG or any of these bazillion extensions, these folders, these files you know of out there. The only thing they really need to, for us in the practical world, they need to be compatible with is linear PCM. So in JRiver, what I can do is I can say, I don't want to use the original format. I don't want to send a FLAC file or an AIFF file to the end device and hope and pray that it's going to be able to decode that file and convert it back into linear PCM. What I can do is I can tell JRiver to specify the output format, and then what I'll do, if you look here, there's a number of different things I can choose. I can choose 16-bit, 24-bit, 128, 256, or 320K MP3. So what I do is I just choose PCM 24-bit. Now what does that mean? What did I just do? I told JRiver, now JRiver, by the way, is compatible with about 40 different file formats. Anybody here heard of Monkey's Uncle? Okay, there's a file format called Monkey's Uncle. Nobody uses it unless you're, living in the fringe Linux world, but it exists, and there's a bunch of these things like that. But what JRiver is being told to do is, regardless of what the file is, it could be AIF, AIFF, MP3, Vorbis, OGG, FLAC, all of these acronyms I'm throwing out, it's going to convert them in the computer to just raw linear PCM, and it's going to send the linear PCM across the network to that device, and that device is going to play that. And we're not going to have any problems. So basically what JRiver has done now, it's made all DLNA devices compatible with one another. You're not going to have any file format compatibility issues. And it will sound better. That's the other thing that's interesting about this feature. Let's just assume your streaming device can accept FLAC without any problem, which tends to be most of them. When it receives the FLAC folder, it has to then open the FLAC folder and it has to reconstruct the information that's in there and turn it back into linear PCM. And it doesn't take a lot of resource to do that, but when you look at the size and the computing capability of these streaming devices, when you look at how much horsepower is in something like this, it takes a very, very large amount of its capability to do that. So think of this as a shot glass, and think of your computer as all the oceans in the world combined. So the processing power required to convert FLAC or AIFF or MP3 or Vorbis back into linear PCM, it takes no processing power relative to the true capability of the computer to do that. So if you're going to play streaming music, this is a great way to do it. Let the computer do the conversion for you. So let me go ahead and play some music for you right now. What happens in JRiver is the devices auto-discover. If you see here, I've got my index over. It's hard for you guys to see because of this screen. Let me zoom this in a little bit. Right here it says DLNA link. That's just the name that I assigned to this device. So what I would do is I would simply just go ahead and I would click on that device, click on audio, scroll through my music, look for something I want to listen to, hit play. Now I was just playing music over the network. I sent music from my computer to the router. Or actually what I did was my computer requested a file from the NAS, sent it through the router, and into the streaming device. Now what's nice about this too is, anybody here have more than one stereo in their household? Okay. Anybody want to play music in those two stereo systems at the same time? With different songs, different sample rates, at different volumes? With something like DLNA, you have a near infinite number of endpoints if you want. You could have 20, 30, 50, any number of endpoints you want to have in your house. The number of endpoints you have in your house is limited only by the capability of your network. So with JRiver, if I jumped on the hotel's network right now, which I did at breakfast this morning, I saw 350 DLNA devices in the hotel. I could start playing music to everybody's TV and just screw with them in the morning and wake them up. So I'm going to talk to the hotel about the security system before I leave here. So it's pretty cool, huh? It's pretty cool. So with this, you could play to different devices at the same time like I just did. And what you can do is you can put an app on your phone. You could put an app from JRiver called JRemote, thank you. JRemote. And when you open JRemote, it will show you in the screen, it will show you all the discovered devices. And so you could select a device, select a song, hit play, adjust the volume right there. So if somebody wanted to listen to one song in one room and another song in another, you could easily do that without any interference and without any compromise in performance. That's the other thing that's nice about this. Another advantage to networking, network audio, is you can go about 1,000 feet from end to end. Now, when you do USB, you can only go about 15 feet. The USB cable is limited to 5 meters. The other thing I like about JRiver, I forgot to ask, who's a Windows user? was great. JRiver on the Windows side is significantly more mature than it is on the Apple side. And one of the things that they've built into let me see where I put this, or where they put it. So many windows here. Connected media. Under connected media, if my computer were on the network, on the hotel's network, if I could get to the outside world, there's actually a web browser built into JRiver. So this is a pretty cool feature. Anybody here use iTunes? Okay. 900 million people use iTunes. It's okay. Imagine if Safari were built into iTunes and you could go to Vivo or YouTube and play it right through your iTunes engine. That's what this allows you to do. So anybody here have a Tidal account? You could go to Tidal.com in the web browser on a Windows computer and then play that around the house. So really cool features. This is a very intensive program, JRiver. It's built by engineers, sort of for engineers, so their logic can be a little bit challenging to follow from time to time, but it has great potential for doing some pretty spectacular things. So I'll take a break here and ask you guys if you have any questions. Yes, sir. JRiver does handle DSD. Let me show you what you can do there. That's a great question. Let's go back into the media network. Let's go into options. Let's go back into our add or configure. And then so what I did was, I'm moving really fast. Let me start again and go slow so you can see what I'm doing. So I go into tools, I go into options, I go into media network, I select add or configure, I drop down the screen on audio, I go to advanced, then I go to DSP Studio, and then it asks me DSD over DOP if I have a DSD capable DAC. So yeah, you can do that. Now this gets real interesting. You know, I told you guys go ahead and convert everything to linear PCM, so you don't have any file issues when you're streaming across the network. You don't have any file format compatibility issues. Some DACs, I find, sound better when they receive a DSD signal. DSD is, you remember Sony's SACD? It's the language, it's the carrier that's used on that. So some DACs sound better when they receive a DSD signal versus the traditional PCM signal. They work better at that sampling rate. They work better with that kind of file format. So you could actually tell, if you want to, you could tell JRiver to convert everything to DSD. Even if it's a 16-bit 44.1 kilohertz, it will upsample it to 2.8 megahertz at 1 bit and send it out as DSD. So it's pretty cool. Or let's say you bought DSD files, but your DAC is not DSD compatible. You could simply tell it that your DAC is not DSD compatible, and when you play a DSD file, it'll be converted to 24-bit PCM. So it can go either way. It can convert your files in either direction. So that's the thing that's so powerful about this program is if you've run into a roadblock, there's typically a solution within JRiver to resolve the problem. Anybody else have any questions? What's that? There are forums up to about 18,000 pages. So you type it in. They're very responsive. Yesterday people asked about things like FooBar or MediaMonkey, and I said those are all great programs, but I prefer JRiver, and this is why I prefer JRiver. They've got 4 or 5 technicians that monitor the forum, and if you post a question, they'll either answer the question or they'll give you a link to the answer to that question that's already been answered several times. So JRiver has absolutely spectacular support for this kind of stuff. They're a remote control? Yeah, you can do it on iOS or Android devices. It does, yep. It it would depend on the end device you're speaking to. So the question he had was, is the remote control, is the volume control in JRiver, is it a digital volume control or is it an analog volume control? And so that would depend on the device itself. So what you can do is you can actually go in and you can configure the volume controls. So let me show you how you would do that. So I'm going to say this is just generic player. I'm going to go into setup. I'm going to select audio. I'm going to select the DragonFly that's connected here. And then I'm going to go down into volume. And volume has a couple of different things. It says system volume, it says internal volume, or disable volume. System volume would be the digital volume control inside of JRiver. Internal volume would be the volume control that's in the DragonFly. Our DragonFly has an analog volume control. So if I set the volume preference to internal, it's going to use the analog volume control that's in the DragonFly. And if I set the volume control to system, it's going to use the digital volume control that's built into JRiver. So it's all dependent on what your product's capability is. So let's say I have a streaming device over here from a company called SOTM, S-O-T-M. This has no volume control whatsoever. So if I wanted to control volume on that particular device, it could only be a digital volume control that's done in the JRiver program. There isn't another option. Or if I wanted to make sure that nobody messed with the volume on that, because I want them to use the volume control on the preamplifier, I could disable volume altogether so nobody can, so I don't have conflicting volume controls. No, that's a little bit deeper than I want to go right now. I already see people looking at me like, what are you talking about? All right. So that is the JRiver program. Those are sort of the basics and the essentials of it. We could do a 6-hour course just on this one particular program. This is a very intensive program.
One more question?
Yes.
Could you at some point discuss the differences between pushing content from your server and pulling content from the renderer?
Yeah, that's a great question or a great lead-in. So the question he had is can you talk about the differences between pushing and pulling? So here's what I'm doing right now is I'm pushing. What that means is I'm using my computer to push media to the end device, what you would call a renderer or a streamer. Some devices have the option to do either or. They do both. Anybody here been following the Auralec Aries? It's a very popular product. It's on, everyone's reviewing it, everyone likes that product. That product has its own little operating system built in and its own application. If you bought an Aries Auralec, or if you bought a Name NDX or one of the Lin streamers, they have something like iTunes or JRiver actually built into the hardware itself. And you would see it through your iPad or your Android device. And in that particular case, what you could do is you could tell that device to pull the music. I'm going to pull the music. I'm an Auralec Aries. I don't want a computer telling me what to do. I'm going to decide for myself. I'm going to go retrieve that file and pull it back to me. And it would have similar setup configurations. You would get an Aries Auralec. You'd put it on the network. You'd go into its system preferences. You would tell it where the music is, and it would build a library. And then from there, you'd be able to pull all the music you want to it. You can use that, though. You can use these hardware devices that pull. You can use them in conjunction with JRiver. So if I were on an Aries Auralec, or if I were on a Name NDX, maybe what I want to do, instead of pointing that Name device or that Aries device, instead of pointing it directly at the NAS, maybe what I'll do is I'll point it to the server that's built into JRiver. That's going to show up in the setup features. Let's pretend pretend that this is the Ares, this is the Orlec. When I go into its setup features, it's going to show the NAS, but it's also going to show JRiver's server as one of the options to pull my library from. And maybe I want to pull from JRiver because it's converting everything to linear PCM, and I know I'm not going to have any file format compatibility issues, because all of these devices that pull eventually crash because they run into some glitch where there's a file format compatibility issue. So this is just a personal opinion, and if you go ask 100 network audio enthusiasts, they're going to give you 100 different answers. Personally, I prefer using a computer over a NAS as my home run for my media content, as my streaming device, as my repository, because there's so much more flexibility to a computer than there is to a NAS. I can use an infinite number of programs. JRiver is just one of 1,000 programs I can use here on the computer, but I can't, there's maybe one or two different solutions I could put on the NAS, and it might not have all of the features that I'm looking for. The other thing I find is computers tend to sound significantly better as a streaming device than a NAS does. And when you start to figure it out price-wise, they can work out to be about the same. A really good NAS is going to run you about $1,000. You know, something like a Synology or a QNAP, a really good computer is going to run you about $1,000. That's before you put the hard drives in it. Okay, well, they're down to $400. You could buy an Acer for $300, $400 too. This is just a personal preference. Personally, I would prefer to use a computer. I like the flexibility that a computer offers and the speed that it offers. So that's...
Just to comment, those like Synology, those different NASs, they have almost really, really limited memory on them, so they can't stream and build those files. So I learned this doing a Plex setup, and so I use an external a NUC device as a...
A NUC is a new little computer from Intel.
Right, and I use that to stream Plex, because that has a full chip on it, it has memory on it, so it can do all of that converting.
It was faster, yeah, it can.
But on a NAS, you can't do it because the operating system is really, really light, and there's no onboard memory, and it just doesn't have the capabilities to do all that. You can upgrade it on some devices, you can upgrade it, but they're not really set up very well for doing streaming, so it's better to have an outboard device to do all that converting.
And you can use them in conjunction like I am now. I'm using both. I'm using a computer to manage the NAS. So I'm using the NAS as if it's just a local hard drive. So you can do either or. So this is the scariest, most complicated way to do things. Let me talk about a couple of tweaks you can do to your network. Let me see where we are on time. And then I'm going to introduce you to some interesting people. More interesting than me. So this has become one of my favorite hot rods for 2015. Let me tell you what this is. So could you stand up? Could you be my lovely Vanna White? Everybody Vanna White. So go ahead and hold those pieces up. Or just hold that one side. So what is this? What am I holding in my hand? This is a bridge. This is an Ethernet to fiber optic bridge. What do I need this for? This is a huge upgrade to any network audio video system. What this does is it breaks the ground. It separates you in terms of noise and electricity. It separates you not only from the rest of the networking that's going on in your house, but everything that's on the pole that connects to your neighborhood, et cetera, et cetera. So network audio sounds absolutely spectacular. It's a really phenomenal format. It's just robust, but you're still going to get noise that comes through the network and into your audio devices. And using something like this, they're about $120. This brand is StarTech. So if you go to startech.com, there's a bunch of different companies that make this. Where would I put this? How would I use this? What you would want to do is you would want to use this in a way that you could separate all of your audio devices from the rest of the world. So let's say that I had just the router in my house. I'm going to stick with just the Comcast router. I'm not going any further than that. What I would do is I would plug the cable from the Comcast or the Cox router into the back of this. I'd go optically to the second box. The second box I would plug into a switch, and then then I would plug all of the devices that are going to be on my audio system into that switch. So everything behind the switch is now optically isolated. There's no ground between it and the rest of the world. No noise in the rest of the world can get into my network system now. These cost anywhere from $89 to $150. They make a night and day difference in the sound of your system. This is a really awesome device. The only drawback to them is their speed. They only do 10/100, which is actually, for the most part, plenty of speed for media devices. You don't need gigabit right now to play music over the network. But if you're uploading and downloading on this side of it, let's say you have a computer that you use to stream your music, but you also use it to upload and download big files, it's going to be it may be slow if you've got gigabit speed network capability in your house. You're not going to get gigabit through this. But in terms of just pure raw audio performance, this thing is spectacular. Line conditioning. Yesterday I talked about line conditioning, and what I had suggested is you should have one line conditioner for all of your audio gear, your DAC, your preamp, your amplifier, etc. All of that should be on one line conditioner. You should have a separate line conditioner, and it should have surge protection. You should have a separate line conditioner for all of your networking and computing equipment. Your NAS, your router, your switches, everything should be on its own line conditioner, so that we're further reducing noise, because all of these devices generate tons of noise. These all have switching power supplies and tons of microprocessors and clocks and things like that, and they're just polluting the electrical system. So your line conditioner is going to function more to capture the noise these things are creating than to improve the power that's going to these devices themselves. But you want to keep that on a separate line conditioner from the rest of your stereo system. Now, I talked a lot about J-River, and in the last couple of weeks, a new program has shown up, a program called Roon. Have you guys heard of Roon? R-O-O-N? You've heard of Roon? Great. You guys are going to be the early adopters. Roon is derived from a company that was known as Sulus. Anybody here remember the Sulus system? It was more or less the first closed container streaming system. You had the touch screen and storage and playback capability and analog and digital out. These guys have made a really powerful program. It doesn't do the DLNA that I just showed you, but one of the things that they've done is they've taken AirPlay to a significantly higher level where you can do multi-room, multi-zone. So let me describe that for you, and then I'm going to hand it off to the Roon guys and let them talk a little bit and show you how their program works. If I'm using iTunes at home, which I do, and I've got 2 or 3 Apple TVs around the house that I use to send music to different locations, which in fact is what I do. I use an Apple TV in my office to play music into a little desktop stereo system, and I use 2 Apple TVs out in the backyard, different parts of the yard, to play music. The limitation with AirPlay through Apple is everything has to play the same song at the same time. I can adjust volume of this song, but I can't play different songs to those locations at the same time. It's just not really designed to do that. The Roon people have figured out and worked out a way where you could play different songs to these different zones. The only limitation with AirPlay is it's really only for CD quality playback at this point. Who knows what's going to happen next week at the Worldwide Developers Conference? It's anybody's guess. But for most people, for their secondary, tertiary zones, it doesn't have to be DSD. It doesn't have to be 24192. It just needs to be fun while you're getting your drink on, right? So I want to hand this off to the Roon guys and let them show you some of the features that this player can do. So this is Enno and Rob, and these guys are the co-inventors of Roon.
By way of background, we've taken a slightly different approach to, for example, to the experience of browsing a music collection than J-River, let's say. As Steve said, J-River is built by engineers for engineers. We think of it as sort of a Swiss Army knife, kind of does everything, but very technical approach to how you deal with music streaming, music browsing. For those of you who are familiar with Sulus and the way it worked, we take a much more sort of experiential digital view of things. So the idea is that in the transition from physical media to digital delivery, there's a sort of an experiential component that was lost. So when you go buy an LP, when I went as a kid to the record store, bought a record, and I'd read the sleeve on my way home on the train, and then I'd put the album on, and I'd read all the lyrics and the liner notes as I listened. It was a very engaging process. There's a real feeling of ownership. So you really feel like you're connecting with the music in a fundamental and an emotional way. And this is the thing that, while we're all trying to solve the technical plumbing problems of how to stream audio to your various devices, this is the sort of the piece that's gone missing, is how do you actually have fun listening to music? So that's the focus of Rune is very much addresses that question. We handle all the plumbing, but we try to obscure that to some degree and get to the sort of just works kind of behavior. Your zones show up, you can stream to all of them. Under the hood, you have access to quite a bit of configuration stuff like what Steve was just showing, but we're trying to that's the second layer. The first layer is how do you interact with this music that you've been collecting? How do you discover new music that you don't know about yet? This is the angle that we're after here. So the way we do this, actually, Steve, do we have an internet connection here? We don't. We don't, okay. Well, the place we started with Sulus, this was 2004, 2005, so the sort of conventional way to display digital music at that point was the iTunes, the spreadsheet view is what we call it. It's just a list of stuff, which isn't particularly compelling if you've been collecting music all these years, whether it's vinyl or CDs or what have you. So we started this interface that was based on browsing by album artwork, because we found that if you've collected this music, you've bought it, you can generally, you don't even need to read the artist and album title. You know it all. You can spot it just by the cover art. So we thought, let's start there. It's a little bit more visceral than scanning a list of text. So this was the original sort of Sulus user interface. It was at that time people mostly had CD collections. So we were looking at this sort of very album-centric view of the world. But we did it by browsing cover art. Now, the approach that we took is, I'm just going to pick something at random here. This isn't my collection, so let's have a look here. Let's pick, okay, Behind the Sun by Eric Clapton. So we've got the album art. What we do is we'll scan the files on your NAS, and a core piece of our functionality is identifying what those files are on your NAS, then going out and talking to our metadata servers and pulling down a bunch of additional information. So not that's embedded in the tags in the files, but we go out and find more information. So here, for example, we've got a review, rating. You'll see the original release date here is 1985, but this version was released in 1999, so it could be a remaster or a later issue. We have a multi-dimensional way of assigning genres. So it's, what you'll typically see in a tag in a file is one genre descriptor for, it could be pop or rock or jazz, something very broad and not particularly meaningful to a music enthusiast. So we'll have here, for example, we've got album rock, contemporary pop rock, hard rock, adult contemporary. So we have a number of ways of classifying these albums, and they can get very, very granular in some genres. Let me show you here. If I go down and look at the track list, you'll see we have, we'll pull in lyrics for the various tracks. So as you're listening, you can read through the lyrics. We're trying to recreate the experience of owning vinyl when there's no vinyl in the picture here. We have credits for the album. So these are also what you typically find in the liner notes. The production credits, the composition and arrangement credits, the performance credits, guest artists, things like that. We have that at the album level, and then even down to the track level. Oh, sorry. Down to the track level. Let me find one that's sort of interesting here. Oh, these are all quite short. But you might have, for example, the backing band or the solo, a guest soloist, or in classical it might be the conductor. All these credits we'll have listed here. Now, one of the other sort of design goals was that typically what you'll see in a media server or a media player, you'll have this sort of hierarchical browsing. You have a list of artists, you can drill down into their albums and then drill down into the tracks on those albums and then back up 2 levels and repeat. And we thought that was kind of a tedious way to engage with the music collection. So what we've tried to create is a more of a natural and linear way of browsing. We never want you to have to back out and go back in and whatever. So everything that you see when you're looking at an album, for example, here is a link. So if I see, I might go to, let's say, pop rock. So I click the genre. Here I've got a collage of my albums that are in pop rock, a description of the genre. You'll see we've got got some artist highlights here, some album highlights, but then I can also drill down into all the various subgenres. So I could say, let's say I'll go to contemporary pop rock, and I get the same thing. And this is, it's not a strict 1 or 2 or 3 tier hierarchy. Some of these, in some genres, these could go sort of 6 layers deep. So it gets extremely granular. This is the sort of, the music nerd experience is how we think of it. So the idea is that I might want to explore very sort of in a lean forward kind of behavior. I might get very actively engaged, or I might just say, I've got people coming over, this is great, I just want to say, play this genre, and we'll just create a playlist based on what this is. So the idea is you can be as active or as passive in your browsing as you'd like. Let's have a look here. Let me go to an artist. So I was just showing you an album, and then we went from the album to a genre, and now we've gone from a genre into an artist. None of this data existed in the files that you downloaded from HD tracks or ripped from a CD or whatever. This is all additional data that we've pulled down from our metadata service. So you can see we have a biography. You might see here where U2 is from, when they were formed, the members that make them up, links to their Facebook, Instagram, Twitter, Wikipedia entries, all that kind of stuff. So we're trying to aggregate all this information about this artist in one place. So where you might have to have 5 tabs open on your browser to find all this information while you're listening, we try to aggregate it all, bring it into the browsing and listening experience. So this is what we feel, for music fans, this is relevant. What you'll find is that if a band is on tour, for example, you'll see their concert dates coming up, sorted geographically based on where you are. So if U2 were playing near me, coming up, you'd see it right here. I could click, go through to Songkick and buy tickets from them. We're trying to integrate all the aspects of the sort of music lover's experience and put them in one place. One feature I'd like to touch on, because I think it's actually truly unique, is how we approach classical music. Classical music doesn't fit neatly into the artist album track hierarchy that's enforced by recorded media, actually, or any of the digital tagging systems. So we took a completely different view. We said, let's look at classical music the way a classical listener thinks of it. So that's based on composer and work and performance and soloist and conductor. None of that fits into the sort of CD-enforced hierarchy data structure. So I will pick, let's say, Mozart, for example. So this looks very much like an artist page, but obviously Mozart's not an artist, he's a composer. So what we're looking at here is, actually, let me see if... Is that same hard drive from earlier connected here? That's kind of strange.
It might just be, it might be a USB or
That's interesting. Oh, title was on. Okay, that's what it was. So let me find someone. So Vivaldi, let's say. So here we've got where and when Vivaldi was born, when he died, the period during which he composed, the genres that he composed for. But here what we're looking at is not albums or tracks. We're looking at works, so compositions. So if you look here, for example, this violin concerto. Here we have a description of the composition, the movements that make it up, the year it was composed, period, instrumentation, form. So this is the kind of stuff that you might find in the liner notes of a CD that's well documented, but certainly you won't find in the files that you've downloaded or that you've ripped. So we've retrieved this information and we've applied it. So now here I see in my collection or in the collection on this hard drive here, I've got 1 performance of this. This is actually really exciting when you see that you have 3 or 4 or 10 performances of a particular work that you can compare them sort of side by side. And then if you have the title integration switched on, you'll see performances of that work across the whole title catalog, which is 30 million odd tracks, what have you. So here I can click through this album, and you'll see the way we display an album is not a list of 1 through N tracks. It's actually tough to make out on the projector, but you'll see those tracks 4 through 6 make up that violin concerto, and so we group them all together. You click play, you get all 3 movements are added to your play queue at once. So for example, we'll never shuffle into the second movement of a work. So this is for the classical user, we like to think that this is sort of a holy grail, because it's not something that you can readily do when you've got a track-based or a file-based browsing mechanism. just quickly, I want to show you what we call our Discover screen. So what we've done here is, again, looking at the experience of how you engage with music. Sometimes I sit down and I know exactly what I want to listen to. I go straight to it and I play it, and that's great. Sometimes I don't know. I have no idea. So what I do is I'll come to this Discover screen, and what we've done here is we've scanned the library on this hard drive, and we've sort of pulled out some insights, the kinds of things that you would only know if you had read all the liner notes to all the albums. So we're trying to be the sort of, the nerdy friend that works at the record store that knows everything about everything and recommends stuff to you. That's what this screen is for. It's new jumping off points to explore the music you already have, and then if you have Tidal integrated, for example, to explore music you don't have yet. So here we'll see, so we'll have, the Bonnie Raitt album released this month in 1991, or actually this Eric Clapton and J.J. Cale is an interesting example. It's called a featured collaboration. So we found two artists that are in your collection that have performed together on a track elsewhere. So it's sort of like a did you know that this was the case? So it's music sort of nerdery, but that's for the music lover, that's these are the kinds of cases that we're trying to address. It's not just about the mechanics of how you stream, but it's how do you interact with it. So that's those are the highlights. We just launched 2 weeks ago, but it's been very exciting. The reception's been really great so far. I think we're probably the only company that's looking at this problem this way. So by all means, please, I hope you have a chance to try it out. Sure.
Can you focus the Discover? So I like these couple of albums. Can you suggest like these albums, or is it always looking at everything?
The way Discover is configured here, it's always global, but there are ways to do, if I go to albums here, for example, here I'm looking at, what do we have, 314 albums. We actually have a feature called Focus, where we can say, I'm interested in seeing my albums from the 80s, or I could drag that to be, to go up to 93 and down to 77, let's say. And now we've filtered the collection based on those criteria, or I could say albums in those years, but only the jazz and blues.
That's not looking at my collection. I'm trying to find other things that might be out there that would be interesting to keep based on.
Because we don't have internet access here, I can't show you that, but the way it works is if you're looking at an album that you own, or an artist who's performed an album that you own, what you'll see right in line there, the way I said you'd have the concert dates, we'd also have all the content available by that artist on Tidal. So on the Eric Clapton example, for example, you'll see not only the Eric Clapton albums that are available on Tidal, but because we ingest the whole Tidal catalog every day, we pre-compute all the connections. So we'll show you all the albums on which Eric Clapton appeared in Tidal. So it's really branching out into the world in a very, very powerful way. But one of the things that we're trying to do experientially is to say, it's not just, a lot of the streaming services, you use their native apps and it's sort of like what's hot, what's trending, whatever. We're trying to say, we use your content as the starting point rather than some notion of, what the top 50 things are in Sweden right now doesn't really apply to me. But if you can show me all the music that's connected to the music that I've collected, we think that's a much more powerful starting point. So unfortunately I can't demonstrate that here, but with internet access and the Tidal integration, that's exactly what we did.
Just wrap back and start beginning on the Tidal integration.
Okay.
Comment on it and step back and start.
Okay, so over the years, we've integrated with a variety of streaming services and different products that we've done. So in Sulus, we had Rhapsody. That was sort of the only service at the time. In the ensuing years, we did a product for HP where we integrated Deezer and Beats and 7 Digital and a variety of services. When Tidal came along, obviously it was very exciting because you have lossless quality, but also they're a fantastic company to work with. And they were the first company ever that was willing to say, sure, take our, obviously you guys do metadata, that's your business, take our whole database and ingest it. So what we can do is we can say, when I click on Eric Clapton here, because I have a downloaded album, let's say, we've already pulled down from our server everything that we know about Eric Clapton in Tidal. So by having pre-computed all of that, we have these links that you can't get this in the Tidal client. It's just not available anywhere. So this is, to us, we think the really key piece is how is your music connected connected to their whole catalog. Philosophically, all the streaming services have the same 30 million tracks right now, but 30 million tracks is a sort of an impenetrable thing. What do you do with 30 million anything? You can't list it, you can't browse it. So, sorry.
$30 million to buy chat.
Okay, fair enough. I stand corrected.
Can't fly.
So the idea is everything that you can browse here in the app, we're always going to show you connections from that thing, whether it's an artist or a performer or an album or a track or a genre, connections from that into everything that Tidal has. That's the idea.
PC and app-based.
Yes, PC and Mac. We just released the Android remote app for it, and iOS is next month. Yes. Yeah. It's an app. It's a local app. So what we've done is we actually built a game engine to make it. We were going to do web-based, but the performance just wasn't there. So from the Sulus days, if you've ever used a Sulus system, one of the things that was sort of notable about it was it's very, very fast and responsive. Everything is sort of sub-20 millisecond response time, so everything feels very immediate, and that's what we wanted to do here. So we actually built a video game engine to be the front end for the app, so that everything is very fluid and very, very fast. Everything's stored in RAM, so yeah, there's never any loading time is what we're after. Yes? Yes, so at the moment we support a variety of streaming protocols, not DLNA or UPnP, but we support AirPlay, which is constrained to 44.116. We support the Meridian streaming protocol, which is up to 96.24, I believe, and we're working on a variety of others that will get us up to 384.32 streaming. That's coming later this year, but that's definitely the direction that we're going, is high quality streaming. We're working with a variety of manufacturers to sort of certify, co-certify that we're delivering bit-perfect streams to their hardware. So that's actually the effort that's underway right now.
And maybe I'll talk about the plumbing stuff for a sec.
Yeah, by all means.
Another question? So, yeah, go ahead.
They don't really work together. They're sort of two different approaches to the same problem. You can run them side by side and see which you prefer. I mean, this is something that happens. You download, install this, run the trial. You'll have this experience right away. So you don't have to build up your collection from scratch. I imported this on Steve's laptop over breakfast. So we just scan it. Yeah, the whole idea is that we're trying to. I'm very pedantic when it comes to metadata. I used to scrub my tags, track by track, sort of ad nauseum. We've tried to automate that because that's a painful process. So even if you're OCD like me, we'd like to do it for you because then it gets you on with the business of enjoying the stuff you've bought as opposed to scrubbing it all day long. So that's what we're going for. It's quite a painless process. Yes? We're working with both of them. I would say by the end of the summer we'll be announcing how we're working with them, but that's the goal. Is our message is that we want to support all the hardware. I mean, we come from a hardware background, but we're not making any hardware this time out, so the objective is to interoperate with all the products that are out there. Yes?
Like right now I have 10,000 songs, download lossless and HD tracks. I'm trying to interface that, be able to get all this information and then, data that you've got here. It's beautiful, it's educational, the whole thing. How would I be able to do that without starting from scratch?
You don't have to start from scratch. If you have the files, if they're on a folder on a hard drive, they're on a NAS on your network, we'll just scan them, and you don't have to do anything. We just do all this.
Excuse me, Enno. You can point to multiple computers, multiple NAS, multiple hard drives at the same time with your program.
Exactly. I should let me talk about that. Do you want to talk about that? You have a great use case for that.
So I'm the least sophisticated person on our team, just period. I mean, my background is in professional audio. I built a couple hundred recording studios, and I've made a ton of records. But in my approach to this stuff, when we launched Sulus, I did not know what DHCP was versus static IP. I had never configured a network in my home other than plugging in a router. I was deeply unsophisticated and been a Mac user for most of my life, which means I'm doubly unsophisticated. And, you know, our goal has always been to make things simple. You're supposed to enjoy the music. You're supposed to have fun doing this stuff, right? That's the reason we're all here, not to mess around with stuff. So to just back out and look at how you would set this system up, right? You would install the app on a computer. Some computer in your house right now needs to be the brains of the system. We're doing an awful lot of work here with all of this data. We have to always talk to the cloud, update the data, all of that. So this chewing happens on one computer in your home. You install the app, and during the setup, it says, where do you keep your music? By default, it's looking for your My Music library on the computer that it's on. It's looking for the iTunes library, but you could have a hard drive attached to that computer. You could have a NAS on the network if you've been doing this stuff already for a while. You might have other computers in the house that have some music on them. You can share the music folders on those computers. So you tell this app where you keep music. Then it goes online and starts finding the information. A 3,500 album collection, it will pull down all of the information, all of these credits, all of these covers, all those photos, the bios. It does that in about 40 minutes, right, for a 3,500 album collection. And then you will have this great experience. Yeah. So that's the basic setup, right? So now in my home, I have in my living room upstairs, I don't have a particularly large home. In my living room, I have a 25-inch HP TouchSmart, all right? Really simple $700 machine with a USB hard drive attached to it, okay? And that's the main brains of my system. I have a Microsoft Surface that I use as a remote for that, right? I sit on the couch in the living room. You know, that's beautiful when my friends come over. I touch it, I engage with it. I also use that machine to like go online in the living room, stuff like that, right? That's the brains of the system. I have a Surface that I use as a remote when I'm sitting on the couch. And that plays out into the living room stereo, and it's wired up into a couple of bathrooms, right, and a couple of bedrooms. But then downstairs in my studio, that's my performance audio environment. As an engineer, that's where my great speakers, my great amps, my Antelope converters are, right? I run that unit as a remote up to that other computer. We have this notion of remotes that can control that main device. And any remote can output to its own audio output, right? So this gives us a couple things. Down in that performance audio environment, I just play out to my Antelope DAC, right? You can also do that on my Surface, right? When I'm sitting in bed at night, online, reading the newspaper, I can plug in the headphones on that Surface and listen through that, right? So that's kind of like this cool flexibility. And then I do a thing with my wife's computer. Downstairs in her office, she uses iTunes to download music. She needs to manage her phone and her iPod. She does all of that very normally, but I've shared that music folder on that computer, set it up to share. That main device upstairs that's the brain of the system watches that folder and knows all about that music, right? It leaves it there, it doesn't move it, but it pulls up all the data, and it's viewed upstairs in the living room. So my wife walks upstairs, and her music to her is right there. She doesn't have to do any work to make it move around or do anything, it's there. So it's fairly elegant in how it works. We tried to set it up so that you can, not do a lot of IT to make things work. Now, audio outputs, right? We can output audio to any device that's connected to that main brain computer. We can output to any devices that are connected to your remotes, right? We can output to AirPlay devices, right? And now all of that stuff with, deciding which format to kick out, we don't do that. we say, what is the maximum that this endpoint can do? So if a AirPlay device can only do 1644, we send 1644 to that. We downsample it and do the work to get it there. If it can do better audio, we send the best audio we can to any device. Now, the other thing that we've done, we have a background making hardware. Sulus was a $13,000 music server system in 2006. And the way it worked was we had three separate kinds of devices. We had control devices, those were our touch panels. We had audio output devices, they were called the source. And we had storage devices. And each of them were independently scalable. You could add as much storage as you wanted, you could add as many audio outputs as you wanted, and you could add as many touch panels as you wanted. You could control from computers and iPads. And the thing is, they all discovered one another automatically on the network, communicated with one another, and streamed, okay? And it was, the hinges on the touch panel would break, the power supplies could blow up in some of the devices. You know, we had the basic hardware problems everybody had. But that protocol that we used to communicate was the most reliable networking protocol ever created for a consumer electronics device. Every review said it's as reliable as a toaster. And for 8 years, we've been making devices in the wild that did that. Now, what we've done, since we're not going to make hardware, is we've taken that communication protocol and we've bundled it up as a little library, kind of like AirPlay gets implemented by manufacturers. We've taken that and we're giving that away to manufacturers. All right, so you asked about Orender, somebody, right? So our first partners will be PS Audio, Oralic, Orender, we got to wrap up. DCS, who am I missing? Anyway.
Audioquest.
Yes. And so we're going to be having devices out there in the wild that, just like AirPlay, the way AirPlay devices show up automatically in iTunes, they just show up. These high-performance audio devices will just show up in our app. You don't have to configure anything, you don't have to do anything. And it's a high-performance format, right? We're doing 384K, 32-bit, we do DSD over PCM, and we clock off the receiving device. This is a subtlety that's important. You want the end device with its high-quality clock to be the master. So this is something that's really important. When all we've done here while we've been here this weekend is meet with other manufacturers. By this time next year, we should have probably 50 companies out there who have this basically high-performance version of AirPlay. So a lot of this work that's going on that everyone's talking about to make things work, we're going to try and make that go away. Because you shouldn't have to. You shouldn't spend $8,000 on a DAC and then have to screw around with all kinds of computer technologies. Because the weird thing about UPnP and DLNA is that they're a specification. They're not really code. It's an 808-page spec, and you pick which pages you want to implement as a manufacturer. And that's why things get funky sometimes. So anyway, that's what we're trying to do, is make something simple and elegant and high performance. So that's it.
Thank you, guys. It's a really exciting program. So we do this type of seminar. We do this for our dealers and our distributors all over the world. And what's nice about doing it for them is we usually get 4 to 6 hours to do all the things we want to do. I try to consolidate really 4 or 6 hours worth of information into an hour, hour and a half presentation, and it just isn't enough. There are things I really wanted to show you today, but we're going to get kicked out of here in a few minutes. I want to give you a couple other pieces of advice, and then we'll have to wrap it up. And if anybody has any questions, hit me at info@audioquest.com. Just to my attention to Steve Silberman, or Steve the computer guy, if you don't remember my last name. A couple of best practices, just when you're doing network audio, whatever it is, whether it's on Roon or it's on J-River or it's on AirPlay. Wireless is terrible. It's just RF interference. That's what it is. It sounds like garbage. One of the demonstrations all of our salespeople do in the field, and a lot of our dealers are doing now, is they actually have 2 Sonos devices set up. The first Sonos device is just wireless. The second one is wired to the network, not even with an Audioquest wire, with the wire that came with your printer, and it sounds a million times better. As hardware designers or as cable designers, one of the things we're trying to achieve is low noise. When you walk around this building and you look at a lot of products, people will talk about how much they've done to limit the amount of noise, RF interference that gets into the stereo system. Why would you use RF interference to transmit your data? So some of the best practices are, if you're going to do network audio, get everything hardwired. We try and make these seminars, too, more about something educational like we tried to do today. You guys know I make cable. You want to know something? You want me to tell you something you don't know? We do make great cable, and our Ethernet cables do sound significantly better than anybody else's cable out there. I really wanted to have some time to demo that, but we're running out of time. Any of our dealers can demonstrate that for you. If you're doing network audio at home, our dealers are happy to loan you any of those cables so you can try it yourself. It's a very exciting and pioneering area. A lot of guys will tell you that it's impossible, that no digital cable can make a difference. If you sat through the seminar yesterday, we had time to demonstrate just a USB cable. The same thing happens with HDMI or Ethernet or anything else. There are things out there, there are spooky things out there that we don't quite understand yet, but they happen. So that's it on the Audioquest pitch side of things. I hope this was helpful for you guys. I hope you guys got a better or more comfortable understanding. Maybe you're a little bit more confused than you were when you came in, which is okay, but if you're more confused, you probably have more concise questions now to ask, right? So again, if you have questions, if you have more curiosity about this, there are a number of local dealers all over the country that specialize in networking and network audio. If you have questions, please email us. We're happy to answer those questions for you. Again, it's info@audioquest.com. My response will come from my personal email address. Sometimes I'll go a couple of days without being able to respond because I'm in Germany or I'm in Thailand or hopefully I'm home or I'm in California at the office. So anyway, thanks a lot. Today's the last day of the show. I hope you guys got to see great stuff. I hope you have enough time to see all the things you want to see. And I'll see you next year. Thank you so much.
Thank you, everyone. Be sure to check out Audioquest in rooms 341 and 343.